Hello everyone. I will invite Mr. Gopal Anand and all our guest speakers to start with the panel discussion.
Starting with Mr. Vikram Murthy. Sir, according to you, what advancements in thermal control technologies are evolving that can enhance air quality and comfort in public spaces?
So this is a nice broad question. So public spaces, first of all, by the very definition, they are public spaces meant for just about anybody to go in over there, unless it's a paid for entry place like an auditorium or something like that. But most public spaces like airports and nowadays railway stations, community centers, and all places like this which are meant for the public are often provided with mechanical cooling or ventilation and so on. So, because of the big problem about the use of energy and energy efficiency and decarbonization, we must have innovations to do cooling in such public places. So, I would just name some of them. So, in dry places and places which don't have much humidity, we can certainly do evaporative cooling in single stage and two stage. And indeed, that is happening in many public spaces. We can do increasingly radiant cooling, which means cooling from surfaces like floors and the ceiling, which greatly reduces the cooling load. We can do displacement ventilation. So these are some of the things we can do to reduce the load in public spaces. And these indeed are the innovations. We call them not in kind cooling. And the other question about indoor air quality. Now, the speakers here and some of us will speak more about that. But certainly, indoor air quality safety is a great concern in public spaces because whoever comes in there must be safe as long as they are there and also go out safe. And so, therefore, increase good quality filtration, air changes, checking to see about the levels of contamination inside. All these are important and these are being done now in public spaces in India.
What are your views, Mr. Sandeep?
I think there are a lot of new technologies that are coming up to make everyone's life comfortable within the public space. And there are a lot of what I would say science and analysis that is going on to bring up a better thermal comfort within a public space. But we still see that not all of that being used in a what I would say as much as we would like to. And so that I would say is a challenge. But there is an approach of system modeling, as Murthy sir said. Energy has become a very important aspect of it. Sustainability, decarbonization has become a very focal point. And when we talk about a public space, it's a really large space. Number of occupant activities are not very well defined. They keep on changing time to time, right? So to design that, to evaluate that is itself a challenge. Typically, there are two approaches people follow. One is prescriptive method, where you just say, okay, these many people, these many things. You just follow a heuristic method to do that. And that is more of prevalent in our industry. And then there is a performance-based method, where you really try to model the whole thing and try to find out what is the most optimum thing for each and every person within the public space. So I believe that is the direction that it is going towards. I had the opportunity to attend the ASHRAE building performance conference in Austin, and there was a big focus on these aspects. That how do we use this technology that is developed for last 20 years by Department of Energy and many other organizations to really improve those spaces. So I think we are still a little far from really using those technology into what is available, and we need to do a lot of work on building awareness about this. I would stop at this with last one example. You might be knowing there is a famous actor in Marathi called Prashant Damle. He's also our president of Marathi Drama Society, and then he's shared one incident in one of the TV show that he stopped going to one of the auditorium because that auditorium was not providing enough thermal comfort. And when he complained to the people that why this is a case, he said it is only issue with your dramas because your drama get houseful. and this is not designed for the full occupancy of a place. So I think that's a little bit of stage that we are. I think we need to build awareness, and we need to do some more to use those things really to do a really effective thermal comfort and then indoor air quality.
How do you view Mr. Jilan Pasha?
Sir, so today scenario thermal comfort has been very critical, and today I say that train is making the comfort spaces in US, in Japan, and India with the same environment. This is possible because of environment. So, as Mr. Sandeep said, the control of the comfort spaces with the occupants is very, very important, because behind this comes the energy. The energy saving is a very, very important aspect, because everybody is on worried today how the energy to be saved and without compromising the comfort. So that is the need of the day today. So shall I give the presentation also now, or that is innovation is very, very important. How the new technologies to be adopted in saving the energy, as well as saving the reducing the carbon footprint is very important in today's context.
What would you like to add, Mr. Deepak?
Yeah, thanks for inviting me. And then the previous inputs were indeed quite valuable. I would rather talk about the air quality, which is my domain. Let me not touch on the thermal side of it. Now, air quality in public places, indeed a very important factor to be considered, both from the social perspective of social responsibility and from the perspective of business element. Now, uh, so under so the first thing is to have an awareness that what is the air quality, and what are those elements contribute to so-called good or poor air quality in uh, indoor public places. So the awareness has to start from measuring the air quality, understand what kind of pollutants are causing the poor indoor air quality, and then address it. Now, the pollutants can either be particulate matters, or it can be the gaseous contaminants. So understanding what kind of pollution, and then then addressing the filtration, having the right filtration system is something very important. There are pollutants which are generated within the indoor space, and there are pollutants when you kind of imbibe, when you take the fresh air inside. So it's important that you connect the indoor air quality with the overall design of HVAC system, and accordingly address it. And also important factor to notice is there are no major mandate or regulations around indoor air quality in India yet. So uh, the think tanks, and then the people who are at helm, it's important to think in this direction, and then see how can we kind of have the uh, uh, you know evolved buildings in next 5 to 10 years. So that's from my perspective.
So, when you talk about the air quality, how technologies can help in mitigating the spread of airborne contaminants in the crowded places?
Yeah, great question. Now, I think it's a question of an hour. We recently had a major uh, global crisis, COVID-19. But now that COVID-19 is specified, and then but at the human well-being is so very important, and that happens from various other bacteria and virus as well. Now, there are various technology that are there available to mitigate this risk. Starting from we have the something called electronic filters, which can definitely arrest the pollutants to certain extent. But if you ask me, the foolproof solution is HEPA filters. HEPA filters have MPPS of 0.07 to zero point 0.12 micron. So, and this virus are often to be seen of size 0.12 micron or 0.10 micron. So, if you use the HEPA filters in the path of air circulation, so that kind of ensures you that okay, you are blocking the transmission of these virus. And HEPA filters operate at efficiency of 99.995% efficiency, typical H14 HEPA filter. Now if you upgrade the rating to U15 U16, that is ULPA 15 16, the efficiency will increase to 99.9995%, 99.99995%. So based on the criticality, you can decide to use a type of HEPA grade. And it's also important to know what kind of equipment are you using to bring in HEPA in the path of air circulation. Now it can be at centralized place like in AHUs. It can be with the standalone equipment within the public spaces. So designing the right equipment and designing the right capacity of the equipment and designing and understanding where to use HEPA filters is something very important. So I would rather conclude my answer to this point mentioning that HEPA is one of the key technology that can be used to mitigate the risk of transmission of virus and bacteria.
Mr. Vikram, he's talking about the filters for large spaces and is talking about the designs also. So, what challenges do architects and designers face in integrating thermal control technologies?
So, integrating these technologies is best done when the designer and the architect collaborate right in the beginning, which is the right way to go about designing of any public space, because this integrated approach to building design is very important and it is being stressed upon. Certainly, large buildings are designed that way, large airports or public spaces like the new Parliament House, they're all designed with everybody coming together. So, the challenges they face are two or three types of challenges. One of the challenges is that the more you want to be good about something, the more space you need. So, one challenge is to have enough space for everything to perform well, the sizes of equipment and the sizes of ducts and so on and so forth, return air spaces. So this is one of the big challenges of space, and often that's a stumbling point between architects and designers. The other one is the challenge of supervising good installation. So good installation is the most important thing, apart from good design, in seeing that the things are being done well. As much as you like to do good things, if they are not installed well, then they will trouble you for the rest of the life of that project. And the third, of course, is to see that we train the client properly to operate them. Because in the end, the life of that building is for 15 years or 20 years, and it's going to perform well based on who operates it. So, coming back to your basic question, the challenges that the architect faces is of being able to understand all the spaces that are needed and also to properly provide for operational efficiencies. And thirdly, to be able to integrate all of these things in his own wonderful design of that building. Because the end customer sees the building, he doesn't look at the services, but he experiences the services. So the challenge is to understand that well, right?
What are your views, Mr. Jadhav, about this? The challenges with the designers face.
So the challenges designer face is, I think, multiple. It's a system. So in a way, like if you see our phone, like whatever Android phone or your iPhone, there is, I think, might be $10 million or $50 million has been invested by design, simulating, analyzing, optimizing. Right? It is being optimized for optimum thermal comfort. It is optimum for everything that you get. But the person who is using that phone, the air quality that he is getting, it is not designed for that. Why? Because building is designed only once, right? So the problem is that we are trying to do it for a thing which is going to be designed only once, and that one person cannot bear the so much big cost of it. So the cost is a definitely big problem, and the physics that we are trying to solve is equally complex. It's not simple. So we are talking about a fluid flow, we are talking about a thermal, we are talking about a particulate matter, what Deepak said, with the filters, we are talking about the CO2, we are talking about so many aerosol and other things. These even rocket scientists will find difficult to simulate. And the person who is sitting in a space, it's not just the diffuser is making impact on him. The type of glass that you use, the type of windows configuration that you are using, flooring that you're using, it's all impacting on you. And so to do that, we definitely need a very good tool set, what I believe, and very affordable tool set. You can't ask him to pay $1 million to do some of those things. And then comes the code compliance. He also have to do a building code compliance. He has to satisfy the spark. So I believe the buildings, the air conditioning system is designed for the people, but people are kept at a last side. They are presumed to have a comfort. There is a hypothesis that they have comfort, or we outsource that to something called thermostat. You got a one thermostat, 100,000 square foot, everyone is comfortable. I think that's the one big challenge and big problem that everyone is facing. So
definitely, Mr. Sanjeev, everything cannot be designed according to like air pollution. So, how would you like to add to it, Mr. Chilani Pasha?
Sir, so this the design aspect has three things importantly. So one is the design by the architects. Second thing is implementation, and third thing is maintenance of it. So systems can be means designed and implemented with high cost, but over the period of time, for example, the life cycle of that building is for 15 years designed it. So the whatever the implemented things has to work over the life cycle of that system, and it has to be maintained, and the people who are maintaining it must have the sufficient knowledge. So what we can see currently in our this thing is a lot of compromises will happen after the system is designed. If something is not performing after 1 or 2 years, it is left aside, and which not only bleeds the energy unnecessarily, and also it hampers the comfort. So emphasis should be given for the maintenance of the buildings for the human comfort and energy efficiency over complete life cycle of the building. So that is my inputs here.
Mr. Deepak, would you like to add to the design aspects?
Yeah. So I think all the inputs were again indeed very valuable. Definitely don't want to repeat on those side of it. But when it comes to the designing the public place for optimum indoor air quality requirements. When I say optimum, it can be as per the guidelines laid by WHO standards or WELL standard or OSHA standard, whichever that specific public place wants to follow. What happens is at the time of design, air quality often seen not gets into the mind of designer because it's not visible. I think often we see air quality to be touched as a topic at the end and or as a miscellaneous factor when the design starts. And what I feel is the scientific approach of selecting the right filter for that particular building is missing. Generally the selection of the filter goes by assumption. Okay, you have pre-filter, fine filter, uh, and then for just to show that there is some filtration, you have certain stages of filter. But what we often see is a lack of knowledge in selecting the right grade of filter. If pre-filter, then what grade of pre-filter? If fine filter, what grade of fine filter? If HEPA filter, then what grade of HEPA filter? So there are scientific ways how the filters have to be selected, and what we don't often see is the element of measurement being plugged in at the time of design. So it's often seen as the external element or the retrofit for when it comes to the measurement of indoor air quality. Now the technology has evolved so much. There are equipment which if are taken as part of design at the initial level of the building concept, the air quality that can be maintained be much more effective than otherwise if you try to then pour in the solution at the later stage of building construction. So those are my views, Mr. Gopalakrishnan.
Yeah, thank you, Mr. Deepak, for the informative sharing. Coming to you, Mr. Vikramurthy, in your opinion, what consideration and best practices should be kept in mind for climate control for large-scale events or facilities?
Mm. Yeah. So this topic has, or this point has come up earlier too when we talked. So for large events, let's say a very large auditorium. Recently, the G20 had their meeting at a place called in the Delhi the exhibition center. What's it called? Mandapam. It's a huge, big space and very large, able to seat 1,000 people and probably more. And so, in such a large space, how do you keep it cool and comfortable for everybody? So that is a special aspect of designing for such spaces. There, you have to have the control from maybe under the seat of that person, so you can very specifically control it. But if you have a very large public space, just take a mall, where people are walking around. They're also pretty large spaces, or take an airport. So over there, often the controls are in two types. One is to control the air motion or the air velocity, and the other one is to control the temperature. So you can set ways of doing both of these things by having very good sensors to sense both the conditions of temperature and humidity and monitor these constantly. But in general, this can be done by very careful air duct and air distribution design. So that's a very big science. It's often given very little importance because we assume if you throw air, everybody will be comfortable. But the design of good air distribution is primary, the way in which you will have even comfort everywhere.
How do you see, Mr. Jalani, what best practice should be, like he was mentioning about the G20, how they could keep cool the mandapa?
Yeah. So the important thing in comfort is as on today we are so much advanced that we having a lot of monitoring tools. So after the design, so whatever is there, for example, the mall or like sir was mentioning the mandapam. So how the space is being controlled in a huge space, we will be having some places will be occupied, some will not be occupied. So how those control will happen, and IAQ like HEPA, what Mr. Deepak was mentioning. So after that, coming out from there in the space, what it is being maintained, like what is the particulate matter there. Like IAQ sensors are very important in current day scenarios to see how the basically the spaces in the big space, the small space, and every part of the space it is maintained. Based on those feedback, we should have innovative control strategy and design of the overall system so that it will maintain the required parameters in every space equally, because some people should not suffer, some people may get more cold air, some people get hot air, or some place the CO2 levels are higher. It should not be the case. So everywhere it should not be maintained equally, because the productivity of each and everyone must be taken care. So design should be such that, and there should also be a monitoring thing from the space, which give the inputs to the complete system to take care of the system. So that is my inputs.
Yeah, thank you, Mr. Jirani. Now coming lastly to Mr. Sandeep Jadhav. What are the emerging trends do you see in the field of thermal control technologies in public spaces?
I think I will fall back to what Mr. Murthy has said, that we have to go towards more integrated approach where the building envelope, the HVAC system, and then the control sequence. It's a combination of all of that will give you a great thermal comfort. So if we can work on that aspect, that we bring all stakeholders together and work together to make that system work, we will able to achieve all our objective, reducing the energy, reducing the impact on climate. We're able to also improve the indoor air quality, and at the most important, the people in the places will be happy and comfortable. So I think a wholesome approach is what is needed.
Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Vikram Murthy, Mr. Deepak Puranik, Mr. Jelani Pasha, and Mr. Sandeep Jadhav.